right, so next we have a fabulous group of panelists that are not here yet, but they're going to come down. So I'll ask them to go ahead and come on down. We have before we get started, I do again want to make sure that you pull out the bio packet from your bag. You will see the full bios for all of our panelists this morning, as well as all of the speakers on the morning agenda. A couple of other things to mention. In your bag, you also have information about the West Tennessee STEM Hub's lending library. The Memphis location has actually just launched sort of a grand reopening. We moved from the McWhorter Library on campus over here to the FedEx Institute of Technology. We got a lot of feedback from teachers that it was sort of difficult to access and then carry 8 million boxes of Connects back to your car because you were parked a million miles away. So what we did was we formed this partnership with the FedEx Institute, so now the lending library has moved over here. We have an online reservation system that we are piloting this year. I found that if you sound kind of sad when you email people because they have a really cool online library platform that you want to use but it's too expensive, they will give it to you for free. So we are trying that out, and we're hoping that we're going to be able to then spread that to the other locations, because we do also have lending library sites at the University of Memphis Lambeth campus in Jackson, and then there's also one at Dyersburg State Community College in Dyersburg. So there are multiple locations where you can access these materials. And the great thing about these is that the kits are fairly expensive, but by using the lending library, you're able to check out a full classroom set, and you don't have to pay for it. So in any case, we're very glad to have the partnership with FIT on all of the work that we're doing with the Hub to make that possible. There's another flyer that I wanted to mention that's in your bag that is about the Brain Awareness Day. So this is an event that's coming up shortly. Registration is available currently. This is something that's being hosted out of UT. So please take a look at that. This is something that your students may be very interested in, and if they're not, then maybe you can encourage them to be interested in this, because it definitely is something that they need to know more about. So with that, we are going to go ahead and get started with our panel this morning, and I'm going to introduce the panelists and then ask each of them to share a few things. But over here on the far my right is Matt Kaiser with FedEx. Then we have right next to him is Allison Powers from ThyssenKrupp Elevator. And then Jenny Bush is in the center here from Cummins Mid-South. Sharon Razi to her left from Medtronic. And then we have Matt Reed from ESC on the far end on the left. So we're very thankful that they were all willing to be here this morning. They have all been incredibly engaged with the work of the STEM Hub, and I'm sure you have probably met many of them at some of the activities that we have hosted in the past. But again, thank you very much to all of you for being here this morning. So what I would like to ask each of you to do, and we will start with Matt Kaiser, is just give a brief description of your company that you work for, the role that you have there, and talk a bit about the types of employees that you hire with respect to STEM.
My name is Matt Kaiser. I'm a staff director of operations analysis for FedEx Corporation. I think you all know FedEx here in the city. Recently we just surpassed about $50 billion worth of revenue, and we connect people and possibilities across the world. We'll ship from paintballs to pandas, from kayaks to trampolines, and yes, truck parts and medical supplies, there really is nothing that we don't handle and connect with our shippers and our customers. With respect to the type of employees we hire, it is absolutely critical that they are people who want to make a difference, that always believe that they can leave something better than they found it. They are simply problem solvers, making the complex simpler.
I'm sorry, I can't hear you at all.
Sorry. I'll go back a little, sorry. So we hire people who want to make a difference. I hire several people a year. I am a very, very small portion of FedEx. I'm not FedEx Express, I'm not FedEx Ground, I'm not FedEx Freight. We are just simply the corporation. But we hire people who want to make a difference, who can make the complex simpler, who follow logic and math and scientific process. I think some of the most critical elements of the type of people we hire are great collaborators who recognize that they are brilliant in their own right, but their brilliance all by themselves won't get much, that they have to do it across a group. So collaboration skills, collective genius, those are the sorts of things that we cherish, and as we build towards innovating across the world, we need that kind of people within our infrastructure.
Hi, I'm Allison Powers. I'm a professional senior mechanical design engineer at ThyssenKrupp Elevator. ThyssenKrupp is a global company. If you want to pronounce it the way my German ownership does, it would be ThyssenKrupp, which I hear on conference calls all the time. I work in the elevator technology business, but globally we have business areas in steel, industrial solutions, making camshafts, crankshafts, fine machining, things like that. But Memphis houses ThyssenKrupp Elevator. The product design engineers are all located in Memphis in the AMS business group, so that would be Canada, Brazil, and the U.S. We have service branches all over the U.S. in all different cities, providing service for our elevators. Yes, we just do elevators, and some people think maybe looking at me, I wouldn't, it doesn't seem very sexy, but if you ever see behind an elevator door, it is plenty interesting, plenty challenging, and I love the company I work for. It's a group of wonderful people looking beyond the elevator, looking beyond the doors, looking to the future with urbanization, what that's going to bring, providing solutions not for just buildings like this, but for the World Trade Center. That was a huge project that we took such huge pride in providing the elevators for World Trade Center. If you want to talk about design challenges, talk about it's actually 1776 feet tall to the top of the spire, so that's a little tidbit of knowledge for World Trade Center. But if you want to talk about building sway and how that affects elevators, that's a huge design challenge that our engineers had to face with. So what kind of engineers do we hire? Elevators are a big robot, so we rely on mechanicals, electricals, and software engineers to all work together as systems thinkers, if you know that word. I'll probably use it again. Not just knowing your specific discipline within engineering, but also knowing enough to understand what questions to ask in other disciplines. It's not just a black box anymore. I'm not just a mechanical engineer that designs the mechanical portion and passes it off to the next discipline. I must know what goes on in software and electrical. So beyond engineers, we have, just like any company would have, good, solid mathematicians well, maybe not mathematicians, but solid in math and finance. And just like Matt was talking about, people who look to collaborate to make innovations for the future. But I won't lie and say that I collaborate all day long. There are few-hour, 8-hour stretches where I have to commit and be focused, and I don't talk to anyone for 8 hours because that's my job as an engineer. So, but then the next day, you know, it's all-day meetings with my project team. So having to go back and forth is extremely, extremely important for anyone that works at my company.
Hey, good morning. You'll notice I don't have the Mid-South twang. My name is Jenny Bush. I am the president of Cummins Mid-South. I actually work for the larger company of Cummins. Cummins is the largest independent engine manufacturer in the world. We're in 190 countries, more than that actually, and we develop, design, service, sell engine and engine-related and power generation technologies. FedEx is one of my customers down here, so that's a good thing. The Mid-South part of the business is the local distributor. So we sell engines into many applications, from something very small, which could be like a street sweeper, all the way through into a very large commercial marine vessel, or data centers for power generation, or into army trucks and vehicles. Many of you may be familiar with Dodge Ram pickups. We develop very small engines from 2 liters all the way to 95 liters. And just to give you a sense of perspective on that, a Dodge Ram pickup would be a medium-sized engine. A 95-liter engine would be equivalent of 16 Dodge Ram pickups together in one engine technology. So we hire designers, we hire developers, we hire supply chain professionals, we manufacture engines in many places around the world. The Mid-South piece of the business services those engines as well as sells them. So we hire technicians, so people that have come out of school and decided they'd prefer to have a hands-on career and servicing those engines. So it's not just about getting a 4-year degree. We're also interested in those people that are able to be good with their hands, problem solve for customers. We sell parts. We design engines into equipment. So we pretty much everywhere you think about power, we have a presence.
Good morning. My name is Sharon Rossi, and I work for Medtronic, which is a global medical technology company. Our products and services help patients, millions of patients suffering from different chronic diseases. The business that's headquartered here in Memphis is our spine orthopedics business. So our patients that we help may have scoliosis or may have been in a traumatic accident and had their spine damaged. So the nature of our products is we make spine orthopedic implants. In terms of who we hire to do that, we hire a lot of mechanical engineers and biomedical engineers like Allison, who we used to work together at Medtronic before she went to ThyssenKrupp. But the broader Medtronic hires probably the full gamut of different engineering types. And then beyond just a 4-year degree, we, because here in Memphis we have our North American Distribution Center because of our close business partnership with FedEx, we also hire people with expertise in warehouse logistics operations. And the other area that doesn't require a 4-year degree is the nature of orthopedic implants is that those bone screws and rods have a lot more technology and precision than your typical carpenter screw. The tolerances are key. We have these complex multi-component geometries that have to come together to fixate the spine and stay put and not back out. And so we have a critical need in the area of sort of precision machinists, which is a specialty that doesn't require a 4-year engineering degree. My personal role with the company is I'm a senior operations director. I have responsibility for 12 manufacturing sites around the world, and my role is to make those manufacturing operations better so that our patients that need our products are never without the therapies that they need.
My name is Matt Reed. I'm a biochemist and a lab manager with a company called ESC. We operate out of Memphis. We have 2 different labs globally. Currently, we're working on expanding that, going into Singapore and Brazil in the future. What we do out of Memphis is we test all animal feed samples for all of our clients and customers within North America. It's about 1,500 to 2,000 analyses per month. I've got a team of about 5 to 6 people. We're actually the laboratory division section of a company called AB Vista. AB Vista sells feed ingredients to farms, feed suppliers, feed mills, etc. We primarily specialize in enzymes. Enzymes are added to the feed to supplement nutrition for animals. They get more out of the feed that they eat. Farmers don't have to overfeed their animals to make sure that they're getting the proper nutrition, help them to grow quicker, better, stronger, and produce less waste. We operate out of 48 countries, have stations in 48 countries, operate out of 70. AB Vista currently has 181 employees, 45 have PhDs. We do, however, have a number of positions that are available without 4-year degrees. People that are driven, people that show attention to detail, and are patient, obviously, because they've got to work their way up. We do develop from within, we promote from within, so we kind of like to hire at the low end and move people up along in their career paths.
Thank you. One of the things that I think is so interesting about this panel this morning is that I imagine there's at least one person on this panel who is from a company that either you hadn't heard of before or you had no idea what all they did. So raise your hand if there's at least one person here that fits that bill. Okay, and so one of the things that I think is so unique about the Memphis and West Tennessee region is that we have such an incredible resource in terms of the companies and industries that are located here. Because we have such impressive transportation infrastructure, we have companies from all different industry sectors that have located here to be able to take advantage of that. And one of the things that I think is always interesting from the standpoint of teachers is it's hard for us sometimes to help students learn STEM content when they don't really understand why they need to know it. And I know that I struggle with this sometimes with my students as well, and it's if you can connect those dots for them and help them understand how something that they're learning in math or in science is really related to something in the real world, because we all know as teachers we aren't real. We've been informed that multiple times. So I wanted to have this group of real people share with us a bit about what they think would be some really interesting and even just maybe some very simple, basic examples of how they use STEM applications within their companies and things that you could share with your students and say, you know what, here's why you need to know algebra, or you know what, this is why chemistry is very important. So maybe we'll start with Matt Reed this time and let him share something that he thinks would be interesting for you to take back to your students.
Our company's strapline is Extraordinary Science Brought to Life. Everything we do lives in science, math, technology, engineering. We are consistently, we're building new products with our engineers. We go worldwide and visit farms, we visit feed mills, and we build new applications for them. We test samples for everybody. Science is everything that I do. It's everything that we do within our company. Our marketing manager for North America is a biochemist by trade, by degree. Our logistics production managers are all pharmaceutical background, and not just logistics production of pharmaceuticals. They're actually lab-based. Everyone has a working knowledge of science. We sell ourselves based off of science. We're one of the more expensive products on the market. It's a highly competitive field, but we offer more technical services. We offer more knowledge than our competitors. We lift our customers up, and we help them find rationale for why their pigs aren't producing the way they should, why their chickens are getting broken legs, and we help work with their nutrition. We have nutritionists in the field. As far as science applications every day, I work in a laboratory, so chemistry keeps me from blowing myself up. Acid to water, not water to acid. Anybody curious? That's a big thing. What not to heat, how to treat different reagents. Chemistry I work with every day. I'm looking at chemical structures. I'm pairing them with other chemical structures to make sure that they will work appropriately. In animal feeds, we're working with different raw ingredients that producers will put into their feeds, and we need to see how to extract the appropriate nutrients out of those feeds. So we work with the chemical structures of everything that we come across. Math. Algebra is probably the most important thing that I do every day outside of just chemistry, which keeps me alive. Algebra, working on dilutions, making sure all of my tests are within range. I do algebra throughout my day, every single day that I'm at work, away from work. I can't stress the importance of math in everyday life within a lab and just even outside of the lab. But real-life applications, when we're doing tests, we have a limited window of absorbance factors that we'll look for. And so we have to dilute samples down to make sure we're hitting our windows. STEM's in everything that we do. It's in everything that we do within our company. If somebody is hired within our company that doesn't have a STEM background, we immediately provide training. They get university courses. They get hands-on, one-on-one training. We need to build up the STEM knowledge base within everybody that works for us, or it's not going to work for us.
Stephanie, your question about why STEM competencies are essential reminds me of my experience as a senior in high school taking calculus, and the way the teacher, very scientific, just did the alphabetical seating in the room, and that put me with a last name of N at the time in the middle row back seat. And my good friend Nancy Joba sat one seat in front of me, and she typically would spend half the class period turned around talking to me because we were good friends. And we had our calculus teacher was good-natured man, and he put up with that, and occasionally would course correct Nancy. And so he asked her to turn around, and she was kind of a bold person, and she just stopped him and she said, "When am I ever going to use this calculus?" And he says, "Well, Nancy, what do you plan to study in college?" And she says, "I'm going to study special education." And the teacher, he was pretty matter of fact, and he said, "Well, you probably don't need this stuff." So she turned around and kept talking to me. But the funny thing about that was that she ends up going off to Michigan State and getting a degree in packaging engineering. So I think we can't take for granted, any of us, that STEM competencies are essential. And I think, the key thing for me is that it's been one of my guiding principles that if you want, personal economic prosperity, you've got to create value for customers. It boils down to that. Focusing on in the business I'm in, whether that's education or technology or healthcare, who's the customer, what's the value this organization is creating for customers, and then how do I fit into that value stream, and how do I contribute? And those value streams end to end, from whether that's understanding your customer needs, again, whether you're a teacher, understanding your student needs, or you're a physician, understanding your patient needs, or product designer, understanding your, in my case, surgeon needs as well. You have to understand the end-to-end value stream. I think Allison spoke to that. you may be doing the mechanical design of the elevators, but you have to understand how that interfaces with people doing the software controls in that. And so those value streams today, I mean, you'd be hard-pressed to find a customer value stream that doesn't have a technical component that requires some science, technology, engineering, math component. And so even if your slice isn't technical, the other parts of the value stream are, and so you have to have that appreciation. And I see that in my own business with people who are in customer-facing roles, maybe in surgery, talking with physicians that really need to understand the therapy of orthopedic surgery. You need to understand parts of the anatomy and the cardiovascular and nervous systems, believe it or not, which wrap their way around the spinal column. So it's just, again, it boils down to, if you want economic prosperity, you have to understand how you create value for customers, where you fit in the value stream, and understand, and increasingly that is technical and requires STEM understanding. So I just, and I think, why is that especially important to West Tennessee? These STEM jobs are good paying jobs. These are strong STEM industries are good for the local Tennessee economy, and if we, it breaks my heart when I hear companies say we can't find local talent here. We've got to fix that to both continue to grow companies like the ones represented here, and to attract new companies that depend on our logistics center of excellence here. So that's my perspective on why these STEM competencies are essential, no matter what students go off to study in college in the end, or do in their careers.
Yeah, I would kind of concur. There's very little actually in the world today that people don't touch that doesn't interface in some shape or form with a STEM element. Even if I just think about a sales forecast or a production forecast or something so very simple. If you don't have a grasp of trend analysis or math or an understanding of a process or an interaction, then it's really hard for you to try to predict something for the job that you have. And it's a really simple example in the sense that, a lot of kids think that it's all, really hard, and, because it's science or because it's math, I'm never going to use it in a real world example. But really what those disciplines are teaching children is how to apply logic and reason, and how to translate that into a real world everyday situation. So if I'm in an engine company and I'm developing a technology, why is an interference between two pieces of metal important? Well, I don't want them to stick together, or I don't want them to, I want them to slide, or I need them to be, durable. You can bring things down into a very simplistic thought process that allows children to understand why that discipline is important in the real world.
I don't like the acronym STEM. I'm just going to say that. I think it tries to digest a huge, huge area of knowledge and competence in one acronym. Scientists, pure scientists, are very different from engineers, who are very different from mathematicians, who are very different from coders, from software engineers. Extremely, extremely different ways of thinking. But the logic still holds. It's kind of the one thing that bridges the gap between all of them. Example, you were just saying, the way my water bottle works right here, every time I latch it closed, I'm amazed. Look at this. Look at that. That took an engineer, not one time, probably 4 or 5 different prototypes in order to make this fit exactly right. And it fits exactly right, not for this one, but every other water bottle that Amazon shipped out. I get frustrated when things are made so, when things are communicated to people that they are just so simple. It's just how the way it works. No, the tolerances of how this fit, every time I open it up, it still amazes me. So I don't know how you teach that to children, but please teach that. Please teach the appreciation of how, look at this, look at how the handrails fit with the lighting, fit with the steps, and everything just fits. It's just amazing. I feel like we should somehow communicate that to kids so they get excited about being a part of that. The one thing in my world, the mechanical spatial skills is extremely, extremely important if we're talking about manufacturing jobs, if we're talking about product design. Being able to see things in 3 dimensions, kind of move yourself around them, have conversations not just with pictures, not holding things, but being able to really explain to someone, okay, if I have this L bracket, what if we flip it around and we put the weldment on the other side? A skill of being able to see that in your head and how that would work and where you would hold it, where it would fit. I think that's an importantly crucial skill for where I sit and a lot of other people that I sit with, software, electrical. That 3D spatial skills is critical. And appreciate this clicking. It's just amazing.
All great answers. I'm humbled by how much wisdom is on the panel today. So I have very few words to describe how amazing the company I work for feels like to me. So I'll just do the best that I can. We deliver 12 million packages a day all over the world. There are very few addresses that we won't go to. That is an enormous machine, and a machine on a global scale that requires a fine-tuning that I don't know, to Allison, to your point, an appreciation of how fine-tuned the ability to pick up a package in Bangladesh and deliver it by 8:29 in Los Angeles, the day after. That's an amazing machine, and it requires significant problem solving, a ridiculous amount of institutional knowledge, by the way, and that's always kind of like one of the things that really disturbs me. When we build decision models, we want to hit the easy button and have an answer, but it is very, very difficult to make decision models, and I've yet to see one that really does great things real time in the transportation space, because we are flying at the speed of sound. But I want to boil it down to some of the things that I work on. I work on fine-tuning operations. So I partner up with other engineering partners within FedEx. They have a particular problem. I have an operations research group that, as I said, are servant leaders, problem solvers, crazy data miners, great marketers, by the way, because I think soft skills are really important in STEM, and have the ability to see a problem, identify the sources of the problem, and then have probably 15 different ways to think about ways in which, how to make that latch fit on a transportation scale. So, we have routing, and one of the things that you could, if people are interested in transportation within your space, you could ask them, so why do we have so many buses, and why do kids have to ride 45 minutes for a 1.5 mile ride, or 2-mile ride? And you could actually help kids, if they were interested in transportation logistics, figure out how to think about the bus routing and how to think about how to fit. I think it's 44 kids. I'm not sure exactly. It's 2 butts to a seat, right? In 11 rows, something like that. And how to minimize, one of the minimized constraints on the model would be how not to have my daughter have to ride 45 minutes for a 1-mile drive, right? So that would be one of the cool things to think about. How do you minimize the amount of time that a bus has to drive? How do you minimize the amount of drivers required? How do you minimize the amount of time that your daughter has to ride on a bus? And then, in totality, guess what? You're never going to be optimal. You're never going to be perfect. What you're going to be is trading off a little bit to the optimal solution. And those are the sorts of things that we work on. That's so exciting. Kids have such great opportunity. The people that I bring into my department are just thrilled to pieces to be able to solve problems. And that is absolutely DNA to the STEM. Hope that helps.
Thank you. Those are excellent examples. So I'm only going to ask one more question, and then we're going to open it up to you, because we want to make sure that you have the opportunity to talk to this panel of experts and ask the questions that are most of interest to you for your students. But the last thing I'm going to ask for you guys to share is a little bit about what you expect to happen in the next 5 to 10 years in the terms of the skill sets or competencies that are needed in the workforce, and share a little bit about that. I'm going to start with Jenny this time, and then everybody else can just chime in as they see fit.
Well, I think we see a couple of trends in our industry that are, one, fairly concerning, and two, there's another trend that's kind of exciting. So the concerning trend is that we're seeing a reduction in the availability of technical skills. And so, you know, kids don't go to technical schools as much as they'll go for an undergraduate degree. And so that means that my ability to fill jobs to service engines becomes really hard. And so I have to think about ways in which I can bring kids into that discipline so that they get excited about a future career, so that we can continue to support all of the industries that are around us today. Because without those technical, hands-on people, you know, FedEx doesn't get to run their trucks. I mean, that's a reality, right? Because we need those people that have the ability to keep things running at a day-to-day practical and tactical level. So, you know, making sure that kids feel as excited about going to get their 4-year degree in engineering, which we also need those guys too, but as well as those guys that are, you know, and girls that are interested in using their hands to solve problems for customers. And so, you know, that's one of our trends. The other trend that is kind of exciting is the complexity and the development of the mechanical and the electrical space. And so what I mean by that is that, you know, technology is becoming much more innovative. It's becoming much smaller, and it's bridging disciplines. So the electrification of mechanical engines and the use of power and waste to make sure that you maximize fuel efficiency is a space that's growing really quickly. So if I use a turbocharger on an engine, for example, to make it go faster or make it more efficient, how do I use the byproduct of that turbo, meaning it spins, to create power somewhere else that I can pull off and use somewhere else on the vehicle? And that way I get a more efficient use of my fuel, which then allows me to reduce the amount of fuel that I use, and, you know, greenhouse gases go down, and all, you know, we fix the world and everybody's happy, right? So, you know, there's a few things that I think that that we need to make sure we develop. So we do need to keep pushing, you know, getting diversity as well into that space in engineering, particularly. We see very few female engineers out there today. When I was in engineering school, I was one of about 500, and, you know, that was kind of weird, and we need to see more of that, as well as, you know, getting those practical and tactical kids that maybe don't want to go to college in the traditional sense and learn, you know, about a technical engineering route, but also an applied practical one.
Yeah, I might just expound on what Jenny said. I think this skill set of being able to work on a team, collaborate, and figure out what the big questions are. Actually, those are critical skill sets. You know, in school we often learn, here's the type of problem, here's the formula approach to solve that problem. But that's not, and those are all important things to learn as well. But, you know, in the
you can say it, the real world.
In the real world, we solve problems on team because they typically are multidisciplinary teams. And I think this is actually one of the reasons why I'm just such a huge fan of FIRST Robotics as an experience for young people in high school, because those require a team approach. They are multidisciplinary, if you will, around the robot design and programming and the safety component, and then, of course, the marketing and business side of it. And so they teach, that's an experience that really teaches hands-on, gives that team collaboration and everyone having their role. And then within that context, I think developing that skill set to figure out what are the questions that we need to answer, which Jenny rattled off some good examples of that. That skill set of just knowing the question, which doesn't happen automatically, right? It comes from just trial and error. Like, I think this is the question, and having a format of constructive debate. And then I think what we can do as educators and industrial partners is help young people figure out what are those questions in a context like FIRST Robotics. So, so we have, coming back to the skill sets around being able to work on project teams, drive collaboration, figure out what the key questions are to answer. And then once we figured out those, I think this basic problem-solving competency, and Matt talked about this several times, and it's not just about problem-solving of, here's the type of chemistry problem or math problem, and here's the formula how to solve it. It's problem-solving frameworks, and I'll just use an example of, to put it in the context of a high school student experience. My son, when he turned 16, and I needed him to get his driver's license right away because my husband and I both work and travel, and I needed his transportation independence. I knew as we changed the system from Mom waking him up, it's time to get up, let's go, to, okay, you're on your own because I'm at the door at 7 now. And I knew right away he was going to oversleep. So, second day, I think, of his driving on his own, I get the call at work, I overslept. Like, he's looking for me to tell him what to do next. I'm like, okay, so this is triage. Put on your clothes, grab a banana and yogurt, and, get to school. But then in the evening is when the problem-solving coaching session happened. And this is what I mean by teaching this problem-solving framework, which is this inquiry-based approach. What happened? I overslept. Why did you oversleep? Well, it was probably something like I stayed up too late, whether that was doing homework or video games, I didn't care, but it was just, okay, you stayed up too late. And maybe there was a electrical device malfunction in his alarm. And so we worked through that. He talked inquiry-based approach, help him through that root cause analysis. Okay, what's your countermeasure strategy? And actually kind of left him on his own to play with that. And, another couple of months goes by, and we have just one other failure. Got a call. I overslept. But so I'm like, okay, so what was your countermeasure strategy? And he said, I set 5 alarms. But so that was working. But I think it's the big idea of that critical competency of teaching problem-solving frameworks that are general, that they can use to solve problems. And I think FIRST Robotics is a great program to be able to experience those problem-solving frameworks.
One more quick point about, I echo everyone that has spoken already. One of the things that I struggled with coming out of school was the new time frame that I now had to be focused to one project. I've been working on the same project now for about 2 years, 2.5 years. Prior to that at Medtronic, it's not uncommon that projects would last 3 years, 2-3 years. In some industries, 10-year projects. So I don't know how you teach this, and this is where you guys have the skill to do this, and maybe it's a proportional increase with age, maybe it's a natural thing, but it's how you teach being committed and focused to a project. One main problem that can also be broken down into sub-problems, but sticking with it and keeping the focus for years and not just the month-long projects that you have in school. I've talked to many of my colleagues, and it is something that you have to get used to, and please figure out a way to teach that.
I think one of the things I'd like to see change is students' perspective. I work in the agriculture industry. It's not necessarily seen as a particular STEM-type field. People think of agriculture, they think of a farmer standing in a field of corn, wearing overalls and a big straw hat, and burning in the sun. And a lot's changed in agriculture since then. The farmer's got apps on his phone monitoring his pigs, his crops, his water intake. He's got Bluetooth connectors on his pigs, on his cattle, on his chickens, monitoring the amount of water, food intake that they've got going on. He's monitoring every aspect of their diets. So farmers are more science-based. Their applications are a lot more science-based. And it goes, further on. They're sending samples over to the lab to determine, what's going on with this chicken's digestive system. I'll get chicken guts all the time in the lab. Pig poop. It's not glamorous, but it's a rewarding career.
We feed people. That's noble work.
We do feed the world, but people don't understand. The students have a hard time coming out of school with the direction of, I want to be in agriculture as my first choice career. I want to be a scientist, and they don't realize that you can be a scientist in agriculture. You can do all sorts of things. I travel the world for my company. They send me everywhere. They send me to customers. I go to UK once a year. I go to Asia. I go to Brazil. It's a very rewarding personal and financial career field to be in as agriculture, and I don't think people understand necessarily where that's going. So what I'd like to see in the next 5 to 10 years is possibly more of a focus on career paths that children can take with STEM, including agriculture. We want kids to start choosing working with pigs and chickens or as a first choice career. It's really rewarding. It's very important. We're a growing world. We're going to be 9 billion people across the world in no time. We're getting less resources to feed those 9 billion people. We get less land as we get more and more people. Land's getting taken away for housing, for apartments. We need to find ways to feed people with less resources, or we're going to start starving. Kind of a big deal. So I'd like to see more of a focus on agriculture and kids getting into the STEM fields, because STEM's vital to everything that we do. It's not just vital to what I do, it's vital to everything everyone does in real life. And I think partnerships with education facilities, doing science fairs, doing talks like this, partnering up and setting up projects for students where they can work on over the semester, something for your company. It's something small, just problem solving, looking at the problems of the future and trying to address them today, and having the children actually work on that with you. Set up different projects. You can work side by side, or you can just assign something and say, hey, can you look at this? And then have a strong discussion at the end. I think partnerships with education and industry are vital in that area, because children do need to kind of know what opportunities are out there. They may say, I want to work hands-on, but they don't necessarily know that maybe they want to go build engines for Cummins Diesel. Or I want to be a scientist, I want to work in a lab. Then they don't necessarily know that chicken feed requires an army of chemists. So I think in the next 5 to 10 years, I'd like to see a shift into that. As far as what kind of STEM fields are going to change in our industry in the next 5 to 10 years, I'd for sure see more automation. I see more engineering involved. We're going to build new things. We're going to build new robots. I just bought new robots for our labs, US and UK this year, that automate some of our assays. We're going to do more of that. We're going to work with engineers. We're going to work with engineering students, hopefully, and have them build more robots and make us more efficient, so we can get results to our farmers and our feed producers in real time, so that they can solve problems as they arrive, as opposed to after it's too late. I think that's...
Again, great wisdom from the panel. So over the next 5 to 10 years, so the threats to us are, what we worry about are, the commoditization of that incredible engine that we run. Shipping's not free, regardless of what you might hear on the internet. So, we are in a constant battle, like everyone on this panel, to do smarter things with less resources. Does that mean less people? No, it does not. It may mean less land. How do I automate a sortation to a greater degree? Anyone been to the hub? How many folks have been to the hub? They have an incredible amount of automation and a long way to go. So your kids could be working on the next generation Memphis hub. One of the 8 engineering wonders of the world, they could be the next iteration for that. So I loved what you said, Allison, about sticking to it. So, I think Edison said he had to fail 10,000 times at making the light bulb before he found the one that was right. We are, by definition, not failures, but we fail a lot. We learn from those failures and learn not to put our hand on that third rail again, and steer ourselves towards better solutions. So, teaching kids that failure is, something that's part of the learning process is an important thing. And I think I'll transition to the skills that I see that are super important to us over the next 5 to 10 years. Data has gotten so big. It is more than a human mind can deal with on its own. And our ability to capture it has gotten better and better. To assimilate it and actually be able to tell a story about it is still a skill that needs to be grown. And, I started in the industry, 28 years ago. I can't believe it's been that long. But what our ability to get data 28 years ago versus our ability to get data today is like off the cliff, exponentially better. And we have great speed to data. We don't have great speed to assimilation. So those are the sorts of things as we learn more and more about how much we can do with the computer. Those are the things that over the next 5 to 10 years are going to be even more critical. Autonomous vehicles, drones dropping packages wherever they want, at a snap of a finger. All those sorts of things that you can dream about are probably something, autonomous vehicles and driving, trucks driving down the road without drivers, probably beyond 10 years because of legislation and other things, not the least of which is, I think it would scare the heck out of all of us. But building solutions faster and with more confidence and being able to build A through F plans after first plan doesn't quite go to script, the ability to adjust, the ability to measure and learn, and then develop better solutions continuously. Those are the sorts of skills, and it's hard to teach, but it's absolutely critical for us to continue to grow.
Thank you. All excellent responses. Okay, so now we want to turn it over to you guys and let you ask the questions. Everybody has a microphone where they're sitting, and the way that you use it is there's a button for you to push to talk. And if your microphone lights up red, that means you've got the floor. So if you push it and you're red, you're talking.
Stephanie, James Stokes at the top, in the center, in front of you. Okay, the question is to the panel, and this has been a terrific conversation today. I love the real world theme. There is tremendous investment being made in job readiness and getting the Memphis area skill sets ready to compete. Continue to stay optimistic and upbeat, but like to hear a little bit about your concerns for our ability to be ready. And in addition to that, I'd like also for you to give us a roadmap, one being additional investment or continued investment, and maybe one or two kind of breakout ideas. Thank you.
How do you want to take that?
Yeah.
Okay.
Yeah.
You want to have a stab? You go ahead.
I'll have a stab. It's a loaded question. But I think, foremost for me, and I'm not a native of Tennessee either, I think foremost for me, when I look at my concerns, I see Tennessee pretty far behind relative to other states on math and science test scores. I think that's foremost. I know we've been improving. We've had some good recent data that says but we've still got a long way to go to, because I think we've got to be leading to be a place of choice for employers like ours to grow our businesses here and attract future talent. And I'm not an educator, not in the administration, but it feels like it feels like an outsider for me, as an outsider sitting on the sidelines, that funding has got to be part of the answer. State and federal funding, I think certainly partnerships like what the hub is fostering between industry and institutions of higher learning and primary, secondary education, nonprofits, I think is also part of the solution. I've just seen great benefits of the collaboration amongst the people on the panel and in the room today. But I do think that there is a place for these experiences that model the real world, whether that's robotics or cybersecurity or other challenges. I think those hands-on experiences that get people excited about the tangible benefits of STEM, I think, I just see every time I'm engaged in one of those programs and you see kids get so excited about this robotics challenge or this cybersecurity, and those, I think, and then this spark that's what I'm going to go study. I think that those are, part of the solution as well. So we got to be doing more of that together.
Yeah, I'll just add a little bit to that. I think Memphis has got lots of social economic challenges. I don't think it's unique though in cities across the U.S. But I do think that it's going to take the businesses and the education system with the city to come together to help that and to make that better. And it's going to take, quite a bit of dedication from those people to invest heavily in the community to help make it better for the future. And that way, you can drive the investment from within, which is kind of really the secret sauce in terms of, helping things grow for the future. Because no amount of external funding is going to solve problems that the people locally don't want to solve. And so if we can bring that together through things like the STEM Hub and the partnerships in the community, then I think that investment will breed excitement and then allow that to grow.
Okay, I think it's on me. My name is Ed Bradley. Let me make sure. Testing. Testing. First of all, it's amazing to hear all of you come here and give us this wealth of information. As a STEM educator myself, you're right, Sharon. We see that our area is behind the 8 ball on where we need to be, but definitely there's been progress. And Jenny, your statement hinges on my statement and question as far as how do we bridge that gap. Someone on the panel stated earlier about awakening purpose in the students to embrace and be motivated for STEM careers. And my school competed in the Medtronics robotics competition this past year, and we will this year as well. An awesome company, as all of your companies are. And we also had an opportunity to go to take a field trip to Medtronics, where the kids were amazed at all the operations of what they do, the 3D printing and so forth. With that being said, and to awaken this purpose, how can we, and I know that a lot of you are the gatekeepers of your organizations, allow students to come in and see these real world things going on. And I'm amazed at the wealth of industry that is in this local community that has not been fully tapped. So if you all can speak to that. And are you willing for us to bring students in and see this to awaken why we should learn science and math and those disciplines? Thank you.
Yes, you are welcome to come to our test facility. So ThyssenKrupp has a few brick and mortar establishments in the city. Where I work, it's not very exciting. It's offices and computers and stuff. But our test facility, where we actually drop stuff, we break stuff, there's loud sounds, there's machines, there's controllers with the controller cabinet open, you can see the software, there's expanded metal cages, you can see the elevator from top, bottom, side, kind of the inner workings of it. We host, it's in Horn Lake, Mississippi, we host about 30 students at a time on quarterly tours. We put hard hats on them, we put safety glasses on them, we walk them around, we talk about friction, we talk about acceleration, velocity, we ask the probing questions, why are we testing this skeleton of a door with weights on it, why are we not test the entire door? Trying to get them thinking about, well, it's expensive to test the entire door. We can simulate the weight of the door with these steel weights that are 2 inches thick. And you're like, oh, okay. So it's not hard for us to do that. It just takes me talking to you, setting up a date, and getting 30 kids on a bus to our facility, getting I think it's important to get the right tour guides that say the right words, that don't look all one way, to try to reflect the type of students that are coming in. I strategically try to do that with the group that we have coming in, men, women, black, white, Asian. I try to get a good mix of people that show, this is what engineers look like. It's not just an old white guy.
Who are you calling old?
I do want to.
It's important, and those collaborations can happen. They can happen. I feel really bad. I'm sorry.
I do too.
But it takes that conversation, and we can do it, and we'd be happy. I'll give you my card. Gwendolyn's here. We want to make those connections to make those more frequent.
Yeah, I would say too, to leverage the network, as I think a number of you are doing, sounds like you're doing as well. I've observed the West Tennessee STEM Hub has been a great connector of industry to schools. There was like just to cite a specific example, in July there was a Collierville School District contacted Stephanie. We need speakers for a middle school STEM camp. She shoots that to me. I shoot that out to our industry partners on the hub. And I also shot it out to, we have a Society of Women Engineers section in Memphis. I shot it out to them, and I think within 24 hours we had all the slots filled.
We did.
Didn't we?
Mm-hmm.
Yeah, so we have a really good network between the West Tennessee STEM Hub and our Society of Women Engineers that we can make those connections happen. Another example was Dr. Chowdhury from Christian Brothers University was put on a Future Women Engineers Camp in June. Maybe some of you are familiar with that. I've sent some students. And she reached out to me, hey, we need engineers of different disciplines to be role models during this course. And again, I shot a note out to our Society of Women Engineers Memphis chapter. And again, we filled every slot, and with men and female role models. But we have a network that we can tap in to make these connections. It's about asking. So Stephanie's the key contact for the hub, and then for the Society of Women Engineers, I'm the current president. So you can contact me, and we have if you forget who I am, know that we have both a Facebook presence and a website.
And we have time for one more question, and I see lots of lights on in the audience, but I'm going to actually let it be from the other room. So we have a whole full presentation theater adjacent to us with people that couldn't actually fit in here. And so I promise I haven't been randomly texting up here. That would make me like the worst moderator ever. But they were sending questions. So I'm going to read it for you. So from the other theater, they would like to know. They said, the conversation today is an awesome start to working toward knowing how to prepare students for STEM-related careers. What is your best idea for convincing parents that a technical path is as good or better than the idea that everyone should be on a 4-year university path? Awesome question.
That's a great question. I think, parents influence kids a tremendous amount. And most parents, I think, hands down want their children to just be successful, and they want them to be happy. And if you can show that to parents in any way, shape or form, then I think you can help them understand what the career opportunities are. The other thing I think is information is a great means of being able to allow parents to be able to coach their children and to guide their kids. So, when we think about career days for kids, we should think about career days for parents, because actually a lot of parents are sometimes out of touch with what's available in the community and how education and careers are changing. Even if I just think about my own children, I've got an 8-year-old and a 13-year-old, and trying to do my son's math at 13 years old, is significantly different to the way I was taught it. So now I have to Google it on the internet, so I teach him the same way that he's being taught in school, right, versus the way that I was taught in school. So giving information to parents and thinking about, as educators, how you do that and how you bring them with you will allow you to then, help you guide your students in the choices that they have. Getting people, the best way to get people excited, for me, is to feel and touch things. And so when they can see it, when they can touch it, when they can experience it, and then they can see success, hands down they're in every time. And so, just think about really basic ways of doing that. It doesn't even have to be expensive.
That's an awesome idea that Jenny just had, the career day for parents. And if I had a pen, I would write it down. So if someone would, thank you, from the hub, we will commit to figuring out how to make that happen, because I think that is one of the best ideas I've heard in a really long time. So career day for parents. We will figure out how to make that work. Okay. So with that, we're at the end of the session. So let's please give all of our panelists a round of applause.